All right.
For two and for one.
So for x plus y equals 4 and 2x minus y equals 5. You got two answers or you got one solution?
Two answers, which is one solution.
Okay, so one solution.
Yeah.
What is your solution?
Negative 3, 1.
So negative 3, comma 1. Now, how could we check that right away to see if that's right?
Graph it.
We could graph it. I don't know that we have that much time to graph it. Couldn't I substitute these values back into my equations?
Yeah.
Now, when I do that, if I put negative 3 in for x and 1 in for y, is negative 3 plus 1, does that give me 4? No. Okay. Positive 3.
Because I was looking at the wrong one.
Okay, so let's try positive 3 and 1. So if I do 3 plus 1 is 4, that seems to work, right? And if I do 2 times 3, which is 6, minus 1 is 5. So look, that works. Now, you did it by way of what? Graphing, elimination?
Solve by graphing.
Okay, so she had solved by graphing.
Because there's a graph where you have 5.
Right. Did anybody else get x plus y equals 4, 2x minus y equals 5? Did anybody get to that one? Nobody got to it. All right, just looking at this, do you think graphing would be the best way to get that solution? Substitution? We could do substitution. Okay. I think there's even a better way to do it other than substitution. Yes.
Oh, never mind. Don't listen to me.
I will always listen to you. What do you think is the best method to use to solve that? Elimination. Why do we say elimination's the best?
Because you can already cancel out the y.
Yeah, take a look at this. You already have two opposites, right? So when you have the positive y and the negative y, you cancel those out, and you could add those together, get 3x is equal to 9, and x is equal to 3. So the best method here, the easiest method, probably to get this, would be elimination. Okay? And you guys don't have this actually on that page, do you?
No, we
At
didn't
all.
have time to do the other one.
Right. So the reason is because you have two opposite amounts that cancel out. Okay? Two opposite amounts that cancel out. All right. Good job. All right. The second system of equations, which maybe some of you got to, maybe some of you didn't, involved y equals 4x plus 6 and 2x minus 3y equals 7. Did anybody get an answer or solution for that? Anybody? No, I'm kidding. Did you say you did?
Not for graphing.
Okay, it doesn't have to be graphing. Did you get an answer?
Yeah.
What'd you get?
Negative 2.5.
Uh-huh. Did you get a y value?
Oh, no. I didn't get that far.
Okay.
Negative 4.
So negative 2.5 was your x amount, and then negative 4. And again, how could I check if these are right? Yeah, substitute it in right away. So negative 4, is that equal to 4 times negative 2.5, which is negative 10? Negative 10 plus 6, does that give me negative 4? Yes. And then 2 times x, 2 times negative 2.5 would be negative 5. Plus 12, because a negative times negative is positive, negative 5 does equal negative 5 plus 12 does give you positive 7. So yes. Preferred method. Which method did you use? Substitution.
That's what we just did. Right? Yeah, that's what we just did. Preferred method.
Well, we thought elimination was the best, though, for the first system because they had two opposites. Here, is substitution a good method? Yeah, because you have y equals all by itself. So you can easily substitute that value in. How about graphing? This first one would be okay to graph. That's in y equals mx plus b. That second one, it would take a little bit of work. Okay. Yeah. Oh, yeah. They would all work. But the preferred method, and what about elimination? Probably not. So you can always use any of these methods to solve, but the preferred method is trying to find which one is going to make it easier. So I would say substitution here. Substitution, because we already have, y equals 4x plus 6 already. We can just substitute this in for x. Okay? So we're just talking about these. You don't necessarily have them. And then the last system, 3x plus 2y equals 8, 5x minus 3y equals 7. Did anybody get a solution? Yes, what'd you get? 2, 1. So 3 times 2 is 6, plus 2 times 1 is 2, 6 plus 2 is 8. 5 times 2 is 10. Yep, that looks good. What would our preferred method be? The preferred method. Elimination. We don't have any two opposites here, do we? Do we have to have two opposites right away? You're right, we don't. I think you are correct. Elimination is probably going to be the easiest. You have no y equals for graphing or for substitution. So if I look at, let's say I want to eliminate my x's, what would be my least common multiple between 3 and 5? 15. So I would multiply this by a 5. Remember, you multiply everything. Correct. And I could multiply this one by a -3, and la-di-da, that's where we would go. The reason, I would say there is no variable that is isolated. We don't have y equals something. We don't have x equals something. So elimination is best. Okay? All right. So, blast from the past. Did you remember some things? A little? Very little? All right. What do we got here? Ooh, we still got 10 minutes. So, just to give you some information, instead of an actual assessment or test, we will have a final project for this chapter. Okay.
Why person B is like all around stuff?
Why is person B what?
Because the elimination method is like more like substituting method, and then substituting method is more like.
Well, we are just assigning different methods for each of them. And then if we had had probably a little bit more time, people would have said, oh, well, this way was so much easier than this way. Because you can solve a system of equations using any of those methods, okay? Substitution, elimination, or graphing. It's just which one is easier for you to do, okay? All right. So, again, we will have a final project instead of a test for this one. Hallelujah. See, give me a test. I'm always a test. But that's the way I run. So now that we're done with this, here's what I'd like you to do. I would like for you to take and actually glue stick this into your book on that page 23 so you can refer to it. So here, have a glue stick.
Thank you.
You're so welcome. Glue stick, glue stick. Okay, glue stick. So paste that in on page 23. That way you can refer to it. What? Oh, okay. Blue stick. You've been here, huh?